Okay, number 10 is very similar to number 9. Look at the congruent triangle shown on the coordinate plane. Again, we have that word congruent, which tells us that these shapes are the same size and the same shape, which means it can only be one or three things. It can be a rotation, it can be a reflection, or it can be a translation. Okay, so just like we tested on number 10, we're going to describe the transformation and write an algebraic rule used to create triangle DEF from ABC. So notice that D and A are both the first, so they both correspond. They're the same. So I'm looking at A right here and D right here. These correspond. Okay, so I'm going to take my patty paper and I'm going to draw the ABC, which is my first shape. I'm going to do a lot better job than that, I hope. Okay. And, wow, that's terrible. All right, let's try this one more time. Okay. Hopefully, you guys get it right the first time, instead of having to take 3 times like I did. But there's my C, there's my B, and there's my A. I'm going to draw my axis. Don't forget to do that. There we go. And then I'm going to test to see if it's a rotation. Okay? So I'm just going to rotate it. There's 90-degree rotation. There's 180-degree rotation. Okay, so this could be right, but I need to make sure that my coordinates match. So my C should match this coordinate. Let's see which one C should be. So I'm looking at C, and C is in my final place, okay? And my final place on this one is F. So C should be the same as F. C is over here, F is over here. So I'm thinking, yeah, it probably is a rotation. Just to double check myself, I'm going to test the reflection and see if it's a reflection. Okay, so reflection is a flip. So I'm going to flip it over the x-axis. Oh, definitely not a reflection, because it would flip this way, or if it was flipped over the y-axis, it would flip. Oh, I'm in the wrong shape. No wonder I'm confused. It would flip this way. So it's definitely not a reflection. It has to be a rotation. Okay, now that I know that, now I can compare one of my points, and I've decided I'm going to compare A and D to figure out what my algebraic rule is. So let's start with A and figure out what it is. So I start at my origin, which is 0, 0. I have to go 1 to the right to get to A, so that's a positive 1. And then I have to go 1 up to get to the A. That's another positive 1. Now moving over to D prime. I have to go 1, that's a negative 1, and I have to go down negative 1. Okay, so I can easily see that my x, y were both positive, and then now I'm kind of confused because they're all 1s. So I probably want to test another one just to make sure. So let's go ahead and test F, since they'll not all be 1s, to make sure that this and this are the same. I want to know, did my y and my x change? And I can't tell from testing A. So let's test C and E. Are these in the same place? No, they're not. So let's test B, which is the middle, with E. B and E. Okay? So here's B. I went 1, 2, 3 over. 1, 2, 3, 4, 5, 6, 7 up. So B is 3, 7. Okay? Then for E, went 1, 2, 3 to the left, 1, 2, 3, 4, 5, 6, 7, to -3, because I went to the left, -7. So yes, my x didn't change places and my y didn't change places, which means my algebraic relationship is -x because it became the opposite, -y. Now, if you'll remember, this is the right algebraic relationship for a rotation of 180 degrees. And is that how far we rotated it? Let's test it. Let's see. There's 90 degrees. There's 180 degrees. Yep, we are correct. We got it.